shit over here.
Yeah, go ahead.
I'm not going to leave the room. I'm going to stay in the room.
I think as long as you're on Wi-Fi, it's okay. I think as long as you're on Wi-Fi.
Yeah, that's why I'm staying right here.
All right, let me unmute this. All right, how are we doing, everybody? Happy Tuesday. Okay, everybody should be on Zoom. You should also have your iClicker app going. So I will put up the attendance while I kind of chat in the beginning. That way everybody can do that. I wish this thing would go away. Yeah. Okay, so I'll let that run for a few minutes. So just as a reminder of what you should have done before you came to class today. Last night you had a homework due. Most people turned it in. Some people did not. It is 0 credit for late work. So you need to turn in your work on time, okay? So that was homework 1, chapter 1 that was due last night. Some people were having an issue. I think that the MyLab system is on a different time zone because it said it was due at 9 o'clock, but there were some people who were working on it at 8 and it was telling them that it was past due. So I set it to 8 a.m. this morning, but I'm gonna have to figure that out. So you will have until 9 p.m. on the day that things are due to turn things in, okay? If something like that happens, just please let me know and I'll figure something out, but I'm gonna try and fix whatever setting it is. All right, let's see. You also should have watched the video lectures from chapter 2, sections 1, 2, and 3. Did we do that? Can I get a head nod, a thumbs up, something? Yes? Okay. You have to stay on top of the lecture videos because if you don't watch the lecture videos and you come to class, you are going to be super lost. So please, please, please make sure you are staying up with the lecture videos. And everybody was able to download the new in-class problems for chapter 2 because that's what we're going to work on for part of today. So make sure you have those downloaded. And I think that's all the announcements I have, but we are going to do some iClicker stuff today for points. So we're going to finish the in-class problems from chapter 1 that we didn't quite finish. We had a few at the very end. We're going to do some chapter 1 iClicker questions, and then we're going to work on chapter 2. Any questions before I start? You're welcome to put them in the chat. You're still having issues with your iClicker app?
Yes, this just started. Yeah, mine too. It's saying that your subscription is fine. No, it's not saying that. It's just saying it won't go before. I bought it. Yeah, it's saying that my subscription has expired.
Have you?
It went on my second password.
No, I know. Y'all try to turn off your devices for a minute and turn them back on and see what happens. It helped a few people. It just resets the connection with the iClicker cloud. So that might help. Anybody else having iClicker issues? Did you go onto Moodle and register? Yep. Okay, so what you need to do right now, I'm going to show you right now. Whoa. Maybe I'm going to show you. I'm going to try. Okay. Here we go. So when you go to Moodle, what you should see, physical iClicker frequency is AA. That is correct. Okay, yeah, so let me show you. This is where to register it. So when you go down and you click on my class, you should see this thing right here that says course blocks. When you click that, it's going to open up all of your blocks. You're looking for the one that says iClicker. Y'all will have fewer blocks than I do. Can you see that iClicker block? Okay, and that's where you register your iClicker. Anybody else with iClicker problems? Let's knock them out before we do any questions. Okay. All right. So let's see if anybody else in the chat. Lillian's still not connecting to the class. And you have a handheld clicker, Lillian? Lillian, do me a favor and send me an email that has your clicker number in it, and I will try and track you down by your clicker number. Okay. All right, so let's go, and we need to finish the first one, chapter 1. Did you hold the power button to set the frequency? That's a good question. Y'all help each other out. Y'all know more about the clickers actually than I do, which is sort of scary. Okay, we're gonna fit our width. All right, I think the last thing we were talking about, did we do this one? I thought we did this one. Consider the following measurements. Did we not do this one? We did, okay. I must just not have saved what we did on it. Okay, so this is one of the places where people struggle with the most. Let me see if I can hide this, this thing so it stops. I don't want to pull. Hide coordinate controls. Okay. And I'll leave that iClicker going, the poll going until we need it so people can check in. Okay, so this is where a lot of people have problems doing dimensional analysis. And when you do a dimensional analysis problem, you always want to think about where you're trying to go. What are you trying to get to? And that is your goal unit. Okay, so let's see what we got here. A mother is to give her child 10 cc's of medicine every 6 hours. Unfortunately, she lost the syringe provided with the liquid medicine. She calls your clinic for help. How much medicine in teaspoons can you instruct her to give the child per dose per day? This is something that really does happen. Okay, so what are we going to do? Well, we want to, so we need to know where we're trying to, what we're trying to get to. What's our goal? What's our goal? Teaspoons. T-E-S-P? Teaspoon? No, T-S-P. I forget the abbreviation. T-S-P. So your goal is in T-S-P, teaspoons. But what are you starting with? cc's. All right, so we know what we're starting with. We know what we're ending with. So start with your 10 cc's. And we're going to do some dimensional analysis. Okay, so if she's going to give her child 10 cc's of medicine every 6 hours, do we care about the 6 hours? Well, look at your goal. It says, how much medicine in teaspoons can you instruct to give the child per dose and per day? So it's teaspoons per dose, and we want to know teaspoons per day. So we're actually looking for two different answers. So let's do the first one. Let's just do per dose. So if we want to get rid of cc's, what do we have to do with that? If it's 10 cc's per dose, and I want to cancel cc's out, what am I going to do?
1 cc equals 1 milliliter.
Put cc's on the bottom, and then I want teaspoons on the top. So I know in 1 teaspoon, we have about 5 cc's. I don't remember what your book, I think your book had a little more precise than that. And I don't know where my chat went. I'm trying to monitor my chat. Okay. So then what do you get? And remember, everybody's got their calculators, right? So you're doing the math right now. You're not just sitting looking at me. You're doing the math. Okay, so what's 10 divided by 5? 2. So we have 2 teaspoons per dose. So that gives us our first answer, right? How much per dose? We've got that. Now we need to say how much per what? Day. So our teaspoons is still okay, but what are we trying to change now? The denominator. So if I want to change per dose, what's in a dose? Like how long is a dose? 6 hours. But hours is not where I want to be. I want to be per day. So I need to do another conversion factor, but in this case, I'm going to put hours on the top so that the hours cancel. Do I know a conversion factor for that? 24 hours in 1 day. Okay, so let's check. We're now in doses per day. Try not to step on that cord. All right, so our dose cancels. We're left with teaspoons per day. Good. So how many? 2 times 24 divided by 6. 8. What are my units? Teaspoons per day, right? And so that's our second part of the question. That's our second answer. So make sure you answer all parts of a question. Okay. All right, let's see. Do another one. Will these be heavily concentrated on the test? No more so than everything else, but they will be on the test. They absolutely will be on the test. Okay, a 38-pound child is prescribed Avoclair for chickenpox at an amount of 80 milligrams per kilogram of body weight per day to be divided into 4 doses. That's a lot of information. Each tablet contains 70 milligrams of the medicine. How many tablets should be given per day per dose? Okay, well, what do you think? Let me see if I can zoom in to give myself a little bit more room. What should we be? We're trying to do how many tablets per day and how many tablets per dose. Right? So we've got really 2 answers that we're shooting for in this one. What I like to do when I'm given a lot of different information like this is I like to write out what they're saying. So if you're given this kid, right, 80 milligrams per kilogram of body weight, right? How many pounds does the child weigh? 38. But I can't really just do 38, can I? Why not? It's in kilograms. This is in kilograms, that's in pounds. So I need to convert that. So how can I convert? And you could start with 38 kilograms or you could start with the 8 milligrams per kilogram. It doesn't matter where you start, you're going to get the same answer. So always use a conversion factor, but that is exactly the conversion factor. So in 1 kilogram, there are 2.2 pounds. Now, how much does a child weigh? 38 pounds. So the question is, right, how many tablets are we given per day? Did we get to tablets? We canceled our kilograms, we canceled our pounds. What are we in right now? We're in milligrams. So give me this in milligrams. Let's like stop and see where we're at. So 8 times 38 divided by 2.2, what do you get? What do you get? 80, thank you. Thank you, Alexis, it is 80. I said 8, it is 80, right there. So 80 times 38 divided by 2.2, what do you get? I got 1,381, yes? Milligrams per what? And it wasn't in here, but really all of this is per day, right? That's what we said, body weight per day. So this is really 1,381 milligrams per day. Does that give us our answer? No, we're not there yet. What do we have to do? We want it in tablets. So how many milligrams is in a tablet? 700. So how did I know to put my 700 on the bottom? It just cancels out the units. That's the whole point. So then how many tablets should she get? $1.97. Are you going to give a child 1.97 tablets? So what do you think you should give the child? Let's give them 2. So 2 tablets per day. It was better when the thing was tilted. Okay. Is my answer done? This was how many tablets per day. This is how many tablets per day. So that part's answered. What about the tablets per dose? So we're still good on tablets, but we want to get rid of that day. And what do we want to change it to? Per dose. So what's our conversion factor? Y'all, please cover your mouths with your mask and your nose. So what do we convert? What do we know? 4 doses in a day. So I want my day on top and my 4 doses on the bottom. And what do we get? 2 divided by 4 is 1/2, right? So they get 0.5 or 1/2 of a tablet per day. That's a real practical application. That's something that you would actually might have to do. Are ready to try another one? You can do this. You can do this. All it is dimensional analysis. All it is changing units. All the information's in the problem. It's just putting it in the right place. The more you practice doing it, the better you're going to be. Okay, let's try another one. Right? Okay. Child must take 10 milliliters of, I don't even know how to pronounce that one, an antibiotic by mouth 2 times a day for 10 days. The solution is provided as a 50 milligram per milliliter suspension. How many milligrams will the child have taken when the course of medication is over? All right. So what do we want to start with? And where are we trying to go? We want to get to milligrams. This is our goal. But that's not what we're going to start with. What are we starting with? Which one? There's lots of information in here. Milliliters. So we're going to start with 10 milliliters of our antibiotic. What are we going to multiply by? So you can do it 2. You're going to take it 2 times per what? Per day. So then that will give us milliliters per day. That's right. Now what? How many days is the person going to take it? For 10 days. Okay. Do we have to have something on the bottom there? No? Well, we're at milliliters, right? We've canceled out days now. We want milliliters. We don't have to have anything on the bottom of that 10 days. It can just be blank. Because we're not trying to find out how many per day, we're trying to find out a total of 10 days. So you could get your answer and then multiply times 10 days, or you could build it into your dimensional analysis. Either way is perfectly fine. So now what? We want to get rid of our milliliters and convert to milligrams, right? So we have 50 milligrams in 1 milliliter. Are we at our goal? Yes. Okay, so now you can plug it into your calculator. 10 times 2 times 10 times 50. $10,000. And my units are milligrams, right? And you could say for the total treatment, or you could just leave your final answer as this, that's fine. Okay. I thought I did the odd numbers in the thing, but maybe I skipped this one. All right. A patient gets 2 liters of fluid for over 18 hours through an IV. The drip factor is 20 GTT per milliliter. Calculate the drip rate in drops per minute. That's what the GTT stands for, drops per minute. So what are we starting with? This is our goal, right? That was pretty easy to identify. What are we starting with? They're getting 2 liters of fluid over what? 18 hours. And I'm trying to get to drops per minute. Okay, so let's do the easy ones first. Let's do the time first. I always like doing the ones that are easy first. So what should we do? I'm trying to get to minutes. So in 1 hour, we have 60 minutes. Okay, so our hours cancel, so we're in minutes, so that's great. Now what do we need to convert? Our liters to drops. So what are we going to do? Liters are going to be on the bottom. What's going to be on the top? Well, do you know a conversion for that? What do we know about GTT? That's right. We know there are 20 drops per milliliter, but we're in liters. So what do we need to get to first? Milliliters. So we know there are 1,000 milliliters in 1 liter. Now we can say there are in 1 milliliter 20 drops. So 2 times 1,000 times 20 divided by 18 divided by 60. So what do you get in your calculators? Y'all got to do the calculators in class. You have to. What do you get? I got 37. Good, yes. Aaron, 37 GTT per minute. So you will see something like this on an exam. I can tell you that. All right, how long would it take in hours to administer exactly 500 milliliters of, what does it say, of fluid through an IV with a drip factor of 30 GTT per mil if the drip rate is 60 GTT per minute? So our question is how long in hours? So this is our goal. So we're starting with 500 milliliters, and we want to get to hours. What's our first conversion factor? We need to cancel out milliliters. What are we given that's a conversion to milliliters? Our 30 drops per 1 milliliter. So our milliliters cancel. Now what? So we use this one. So 60 GTT per 1 minute. Are we in the right unit? No. I promise you that'll be a choice on the test though, on the exam. Like if you do the math right there, and I'm asking you for how long would it take in hours, how long it would take in minutes would be one of the answer choices. So you have to be very, very careful that you're going to the right unit. Okay, so we got to keep going, right? So we need 60 minutes in 1 hour. Now we're at the unit we want. So do the math. 500 times 30 divided by 60 times 60. And I do suggest you bring the calculator that you're going to use on the exam to class so that you have practice using it. So what do you get? 4, yes. So 4, if you put it in your calculator, you get 4.17 hours. But tell me about significant figures. How many significant figures do we have in all of our values? 1. 1 significant figure. So our answer must be in 1 significant figure. Okay, I think this is our last one, isn't it? Yay! All right. So this one is actually not a conversion. This is a percent, right? So a medium-sized carrot weighs 61 grams and contains 6 grams of carbohydrate. What percent of the carrot is carbohydrate? So whenever you're doing a percent, you're looking for the fraction, right? So a percent really means over 100. So how should I set this up? How many points, let me see. How many points we get off on the test if you answer 4.7 instead of 4? I'll have to get back to you on that answer. I'm not sure yet. I will get back to you on that answer. Send me that in an email and I'll remember to make a decision on that. Okay. So a medium-sized carrot weighs 61 grams. So this is our total, right? That's our total mass. And this is our part, right? A carbohydrate, there's more than just carbohydrates in a carrot. So this is the part. So what percent of the carrot is carbohydrate? So how do we set that up? We would say we have 6 grams, that's our part, is equal to some percent of our total of 61 grams carrot. You could say 61 grams of carbs. So what does that percent mean? It really means over 100. So what do we want to do? We want to say 61 and 100. We want to flip-flop them, put them on the other side. 61. So x is equal to 100 times 6 divided by 61. So you see, by doing that, I just cancel out all my stuff on the side with the variable. So what do you get? I know y'all have calculators. I know y'all are doing this. What do you get? 9.8%. Good, 9.8%. Is that the right number of significant figures? No, it's not. This one only has 1 significant figure. So what should our answer be? 10%. Good? Why did I put 100 over 61? Is that what you're asking? So when I have, this is what I started out with, 6 is equal to x over 100 times 61, right? So what I want to do is I want to isolate my variable. So in order to isolate my variable, right, what I'm going to have to do is do the inverse, right? So that would be 61, and what I do to one side, I do the other. So my 61 cancels here, and I move it to the other side. So, what? And then you have to do that same thing for the 100? Yep. Yep. So I just combine that into one. I just said 100 over 61, right? Times 6, right? And you had 61, you had 100, and so I just combined it, 61 over 100. I just did it kind of all at once. So my 61s would cancel, my 100s would cancel, and I'd be left with x all by itself. So it's just isolating the variable. Okay? All right, y'all ready to do some clickers? Y'all got this. All right, I'm gonna stop this one. And if anyone's confused, all you have to do is cross multiply. Yeah, same thing, cross multiply. Okay. And now I'm not gonna save my changes. I'm gonna come over here. All right, and I really like to play my slideshow. All right, so these should be pretty easy, some of them, I guess. Well, I guess we'll see, right? Okay, so which of the following is not a pure substance? Steam, ammonia, gas, or iodine crystals? Thank you, Lillian. We're kind of going to talk about each one after and explain why. And I'll give y'all until, I don't know, 55. We should have more than 78. My clicker is not working. Okay, please send me an email and email me your clicker ID and all that, and I'll look into it later this afternoon. Okay, so what do we get? What do we decide? Okay, so in order to be a pure substance, what do you have to be? All what? All the same thing. Is steam all the same thing? Yes, what is it all? It's all water, right? Ammonia. Ammonia is all ammonia. There's a chemical formula for ammonia. Iodine crystals. It's all iodine. So which of the following is not a pure substance? That would be gasoline. Okay? Let's see. Okay. Which of the following substances can be classified as a homogeneous mixture? A homogeneous mixture. Go back and remember your vocabulary. And you can use any resource that's sitting in front of you. You got notes? Okay, I think I'm gonna start calling the questions at 1 minute. 1 minute should be good for everybody to answer. So if you haven't answered yet, please answer. I think we're up to 78. Okay, oh, we got one more. Okay, I'm calling it. All right, so which of the following is a homogeneous mixture? Well, I know water is a pure substance, right? It's all H2O, so it can't be that. Hydrogen is all hydrogen, so that's a pure substance. My only two things here that are mixtures are salt water and oil and vinegar. What do you know about oil and vinegar? They don't mix, they separate. So is that homogeneous? Is that all the same? No. So my only homogeneous mixture should be salt water. Okay. All right. How many hydrogen atoms are in this molecule? Now be careful. I'll give you a little extra time on this one because I know you got to calculate things. You got to add things up. Okay, I believe 79 is our max number today. Okay, so what did we get? What did we say? All right, so the answer is C. The answer is C. Shall we count them up? Should we show what we did? Right, we have 3 here, maybe. Can I not write on this? Oh, will it write? I can't write. Well, it's writing, but I'm writing over there and it's writing over here. This is really, it's about that far off. That's really strange. Oh man. Okay, let's see if I can get this. So there are 3 in the first one right here. Then how many are here? 14. See, I can't even tell where I'm writing. And then how many are here? 7. So then you have to add them up. This is really difficult. I'm gonna have to figure out why that's not working. Okay, so then you add them up and you get 24. All right, and why did that not go away? All right, now I want you to, oh, that one was correct, okay. I want you to try to find the element in period 5 and group A. Period 5 and group A. I did not mean to completely get rid of the chat. All right, y'all 1 minute, y'all need to ring in before 1 minute. All right, so what do we get? So we said indium, so period 5, oh, I can't write on this. So period 5 And we're gonna go across and we're going not to 3B, but we're going all the way to 3A. So 3A is indium, so that is correct. Okay. All right, now here's a balancing equations one. What is the coefficient for O2 when this equation is balanced with the lowest whole number coefficient? I know this one's gonna take you a minute, so it's okay. I would write it down on a sheet of paper. Question. I'll give y'all until 5 minutes. Okay, take a guess. If you don't know, take a guess. Don't leave it, don't ever leave it blank. Please, for me, don't ever leave anything blank. At least you have a 1 in 4 chance of getting it. So please don't leave it blank. Okay, so let's see what we got. All right. So what you should have gotten was a balanced chemical equation that looks like this. 2, 7, 4, and 6 should have been your coefficient. And I would write it out and show you how you balance it. But for some reason, didn't want to write on this. So what I'll do for y'all is I'll make a little video of just balancing this equation. Does that work for y'all? I'll make a little video and I'll post it, and I'll send y'all a little notification saying I posted it. I probably won't be able to do it till tonight, but I'll do it, okay? Because whenever I write, let's try again. I'm like way up here on the screen. Terrible. Okay, let's see. Okay. I don't know. Okay. I'll have to figure out a different way to do this. But that's okay. All right. Which of the following is a chemical reaction? Ooh. Which of the following is a chemical reaction? Liquefying oxygen, rusting of iron, melting of ice, or slicing a ham? Okay. So, which one is a chemical reaction? What did y'all say? Rusting of iron. Very good. Rusting of iron is correct. So why is liquefying oxygen not a chemical reaction? It's just changing states. It's like saying freezing water. It's just a change of state. That's physical. You're not actually chemically doing anything. When iron rusts, iron reacts with the oxygen in the air and creates iron oxide. So that's definitely a chemical reaction. Ooh, I did not mean to do that. I'll have to go in and fix that. Because I know nobody answered that and I clicked it. So I'll fix that. Sorry. Okay. Here's a little math question we need your calculators for. What is the percent by mass of salt in a mixture that contains 150 grams of salt, 1.2 kilograms of flour, and 650 grams of sugar? I do suggest a sheet of paper to do this one. I'll give y'all 3 minutes to begin. Let me know if it's not. Anybody else having these problems? Julie's just sent me an email about that. Send me a screenshot of what it looks like. Okay, well, 70% is an A, so even if you miss a question, don't freak out, y'all. 70% is an A. Don't freak out. Y'all gonna need another minute? We only have 50 responses. Okay, I'm calling it at 4 minutes, so if you don't have a response, attempt one. Yes, I'm gonna explain this one after. I actually have this one typed out. Yes. Okay, so let's see what we get. All right. Ooh, we have a big spread on that one. All right, so let me show you how this works. In this question, it's telling you that you have a mixture of multiple parts, right? We have salt, we have flour, and we have sugar. So it's not telling you what the total mass is. So what you really need to find out is the mass of the mix. The mass of the mix is the sum of the parts. So the total mixture, that's the whole. So we really need the sum of the parts. Well, you were given 150 grams of salt, 650 grams of sugar, but what are your units over here? They're in kilograms, so you have to convert that. So you have to convert from kilograms to grams. So now I have salt, flour, and sugar all in the same unit. And then I can get a total of 2,000 grams. To find my percent of whatever part I want, I put the part over the whole and multiply times 100. So I have 150 grams of salt over 2,000 grams of the mixture, multiplied by 100, we get 7.5%. Okay on that? Now that we've seen it kind of explained. So just be careful that you actually have the total. You know what the total is. Okay, these are some easy ones. These shouldn't take you long. How many significant figures are there in the following number? 0.00458 grams. How many significant figures? I'm calling it 1 minute. And we got 80, so we can call it. Okay, so what did we say? 3 significant figures, that's correct. So how did you know it was 3 significant figures? Oh, I did that again. Okay, 3 significant figures. Is the decimal present or absent? Present, so you're gonna come in from this direction and cross out those zeros until you get to your first non-zero number. Your first non-zero number is a 4, so everything after that 4 is significant, so you get 3 significant digits. Okay. The average diameter of a human cell is 0.000050 meters. How many significant figures does this measurement contain? Okay, 80. All right, so what did we say? So this measurement does contain 2 significant digits. So if we look at that, right? The decimal's present, so we're going to come in from the same direction, and the first non-zero number is a 5, and everything after the 5, even if it's a 0, is significant. So you have 2 significant digits there. That's correct. So 2. All right, identify the number of significant figures that the syringe measurement should be reported. So here's your syringe. How many significant figures should we report? Okay, we got an E. So what did we say? 1 significant figure? Only 1? Why only 1, y'all? If here's our measurements, right? A big tick mark is 0.1, right? So if I go to another big tick mark, that's 0.2. So I'm looking, I have tick marks now that are smaller. So I'm telling you that every tick mark is 0.01, right? So that's 1 place past the decimal, that's 2 places past the decimal. Now what if I had, let's just say this much right here? What would you tell me that measurement is? 0.1, and then I'm between 0.15 and 0.16, right? So I would say that's 0.155. Because you have to give whatever you can read and 1 estimated digit past that. Right? That's from, yes ma'am. But it's the same thing. It's the same, identify the numbers, the number of places past the decimal or the significant figures. It's still the same thing. It's still the same question. It's still 3. Because you're going to give the 10th place, that first digit past the decimal, that's a major tick mark. So that's 1 place. Then the minor tick mark is the next place. And then the last thing is an estimate. There's no tick mark for it, so it's an estimate. So it's either, you could say 3 places past the decimal, or you could say 3 decimal places. Either one, it's the same answer. It would be sig figs.
Like for 0.01, that's only 1 sig. You know what I'm saying?
I get what you're saying, but you don't know where, there's no liquid in there, right? So if you're saying for this syringe, what's the significant figures for this syringe? It's 3. Even though if you only had a little bit, you would have 0.001, right? But you don't have a liquid there. Okay? So if you're asked about a measuring device, any measuring device, a ruler, a syringe, anything, right? And you are looking for the number of significant figures, you look at all the tick marks, and then you estimate 1 past. So we have 2 tick marks, the big tick mark, the little tick mark, and we're going to estimate 1 more. Okay? So I'll leave that one ungraded for y'all. Yes, I'm sorry. Oh, in the chat. Thank you. So if we're reporting the 0.1, if you were reporting the 0.1, if you had 0.1 exactly, you would really be reporting 0.100. That is correct. That is correct. Yes. Okay, so now let's try to apply this. Let's try to take this measurement. Okay, so Tell me how much fluid is in this syringe with the appropriate number. Oh, it's a poll. I didn't want a poll. I wanted to do a numeric answer. Okay, we're going to try this. I've never done a numeric answer before. We're going to try a numeric answer. Sorry, y'all. And if you'll notice, it's the same syringe as in the previous question. It's the same syringe.
How would we answer that online?
Oh, I forgot. It's okay. I won't count it. I won't count it. Write down your answer. If you have a handheld clicker, write down your answer. That's a really great point. And see, I've never used those before, so I won't count it. But write down your answer so you can check yourself. Write down what you think it will be. So I'm not waiting on 80 responses. I forgot about that. Some of y'all have regular clickers. I'll have to make those multiple choice from now on. It's all right. Okay, so let's just stop because not everybody's going to answer, so it's okay. So let's see what the results look like. Okay, so we know we're 0.3 something. We get a lot of 0.3. Oh wow, that's a lot of different answers. All right, so what we really are looking for is 3. We know we're past 0.3. Now this is the 0.35 mark, 0.36. 0.3, it looks to me like it's right on 0.37. So I'm still gonna have to estimate that last digit. So I would estimate that as 0.370, right? It's not between the graduation marks, it's right on the mark. Mm-hmm. It's okay, I'm not gonna count this one because people with handheld clickers I didn't think about that. So I'm not gonna count it, it's okay. I'm not gonna count it. But how would you answer numerically on an iClicker? You can't. I'm sorry. I'm not gonna count that one, okay. So let's try this. Oh, wow, I gotta stop doing that. Multiple choice. All right, identify the number of significant figures in the thermometer. Okay, so we have 80. So what do we say? Good, good. We're gonna report this one. Why do I do that? We're gonna report this one to 4. Why didn't I give an estimation? There's 4, 1, 0, 1, 8. That's 4 significant figures. Why don't I have an estimation? Why isn't it 5? It's electronic, you can't estimate. You can't. So if it's electronic, you give what's there. If it's graduated, if it has marks, then you have to estimate. Okay. I have another question in the chat. Oh. Do you have to include the 0? Yes, you include the 0. Any 0 between 2 non-zero numbers is significant. But the easy way, right, is here's the decimal place right here. So if I'm coming in from the left, what's the first non-zero number I hit? This 1. So everything beyond the 1 is significant. So that gives you 4 significant figures. So you basically guessed for the third. That's right, Taylor. That's right. That's right. Okay, Brent, I'm sorry. Okay. Good. She got it. All right. Convert. We need to do a conversion. And I didn't give you this, so write this down. Write this down. You have 4.184 joules in 1 calorie. You have 4.814 joules in 1 calorie. 4.184. I'm sorry, 4.184. 4.184 joules in 1 calorie. Sorry. Okay. Make sure you answer the question in the units that were asked for. I'm going to call it at 3 minutes. Oh, we have 81 responses. Did we gain somebody? Okay, so what do we get? So the correct answer is A, 56.4 kilocalories. Now, be careful with units. Be super careful with units. When you go from kilojoules, right? We're trying to use this conversion factor that I gave you. 1 calorie is 4.184 joules. So we convert from kilojoules to joules. Then we go from joules to calories. So you probably did that math and you got something like 56,000 calories. That's not an answer choice. But what is an answer choice? We have 2 answer choices that are in kilocalories. So try it. What happens if you convert from calories to kilocalories? You need to know what kilo is, right? Kilo is 1,000. So in 1 kilocalorie, you have 1,000 calories. 56.4, 56.4. Be careful that you don't just give this answer, because that's not right. The correct answer is either 56,000 calories or 56.4 kilocalories. Okay, so be very, very careful. Be very careful. Okay. This is the end, because this is our, here's a conversion. This is in the medical field conversion, right? Okay. So melatonin can be prescribed to children 1 to 8 years old to reduce anxiety before surgery. If you have a 50-pound patient and the dosage is 0.5 milligrams per kilogram, how many grams of melatonin should you give your patient? Be sure to use the appropriate number of significant figures in your answer and the units in grams. Oh, I don't know why I'm doing this, because this is another one that I did in as a number. So just try it right now. Try it. I'm going to stop the poll. I'll give you about 5. I'll give you until the end of class almost. Right? What are we in? 120? We didn't get as far today as I thought. I'm going to make a video. I don't remember if I wrote this one out. I think I wrote this one out. I'm pretty sure I did. We will see. If I didn't, I'll make it in the video tonight. No, this one's not going to be counted against you because nobody responded. I'll fix it. Don't worry, I'll fix it. Give me a thumbs up if you have an answer. If you have any answer. Okay, I'll give you about another minute. Okay, so you should have gotten an answer that is 0.01 grams, right? So you started with 50-pound patient. We converted the pounds to kilograms because that's what our dosage is in, milligrams per kilogram. So now we're in kilograms, and we have a 0.5 milligram per kilogram, so we use that as our conversion factor. Then we go from milligrams to grams. Okay. All right, so we did not get as far as I thought we were going to get today. So your homework tonight is to watch, and I will post this on the calendar. It's gonna push some things back, but that's okay. We're gonna roll with what we got. So your homework tonight is to watch the 2.4 and 2.5 videos, chapter 2, section 4, chapter 2, section 5. I will post it on Moodle in the calendar. Y'all know where the calendar is? This is the calendar you should be checking all the time. Let me see. Let me show it to you before you walk out so you know where you are going. So over here. Here we go, pre-recorded lecture schedule and homework calendar. So anything you need to have turned in, this is where you're gonna go. So right here, I'm gonna put chapter 2, if I could write, if I could type, I'd do it right now. I'm gonna put chapter 2, sections 4 and 5 right here. But it's gonna push back our homework and stuff, and I'll go in and fix that, but it's just not letting me edit. I guess because I'm not signed in. Okay, y'all are good to go? Yep. Can you leave the iClicker thing? Yes, you can leave the iClicker. I'm going to end the iClicker. I'm going to end the iClicker in class. Okay. And it's full screen. All right. Let's see. I want to see my chat, see if people need something. What you got, gentlemen? Let me turn off my microphone so I'm not.
Every time, like, I entered my clicker into the thing online,
Uh-huh.
and it just won't let me put in the base.
Ain't no base. Try AA.
I've been trying all class.
Anybody else have a handheld clicker who's really good with a handheld clicker?
Whenever you connect it, like whenever I would connect, I would just like wait to log on.
If you have an